Hello and welcome. Today we are going to be talking about binary search, a very effective method or algorithm for finding a specific element in a sorted array. It's good to note that anytime you're in an interview and you see an array or some sort of data set that is sorted, chances are the underlying pattern or a good pattern to reference would be binary search. So it's very effective because it essentially divides the search area in half on each iteration. So we're going to take a look at some code to write it and the concepts behind it. Again, anytime that you're working through lead code questions or coding interview questions, it's good to just think about the underlying patterns and visualize it as best as you can. So essentially what we're doing is we're starting with our binary search function is accepting an array and the target, which is what we're going to be looking for. So just to kind of visualize this really quickly, we can see that we are starting with the full array. And on each iteration, we are we're basically cutting in half the search area. You're going to see that reflected in the code as we go through and we eliminate portions of the array. One way I like to think about this is it's just like if you were to grab a phone book, you would have one hand on the start of the phone book, one hand on the end, and then you'd probably put your thumb down the middle and kind of search that way. So we're going to see that reflected in the code. So let's go ahead and start visualizing our phone book. We want to get our start. This is going to be basically your left hand that's grabbing the cover. The phone book, we're starting at 0, which is basically, again, this is 0 or the beginning index of the array that is being passed to this function. Then we're going to define the end variable. This is just going to be the end or array.length -1, so we can get to the last index. And from this point, we are going to look at doing an iterative solution. Now, of course, we could do this recursively, but we're going to go ahead and write a solution or iterative solution. So we're going to iterate through the array. Now, just like we would place our thumb in the middle of the phone book, we want to define our midpoint. We're going to find the middle of our array. We're doing math.floor just so we can round down. But essentially, we just say start plus end, and then we divide by 2, and this will give us our midpoint. And from here, we can actually start to get into the main logic behind what we're going to do. So we're going to say if our midpoint is less than our target, then we're going to say start equals mid plus 1. So essentially what we're doing here is we've defined our start. We have our start point, we have our end, and we have our midpoint. So what we're doing is we're saying less than. If the midpoint is less than, we're effectively saying if it's not in this section, let's just disregard this portion of the array. And then we say start equals mid plus 1. So we're basically going to the midpoint and we're saying, hey, move one slot over so that we can target this area. That's essentially what we see here as well. Like in this case, in the next iteration, we've eliminated the entire left hand side of our array. So our search space is reduced or halved. And then we're going to write the code for the opposite of that. If our target happens to be on the left-hand portion, we want to eliminate the right side. So we say just mid is greater than target. We can say end equals mid minus 1. Now, of course, if we don't find the target on the left-hand side or the right-hand side, then we know that it is the middle point. So this is a case where you open a phone book, you split it down the middle, and you say, oh, I happen to have just opened up exactly to, or roughly to where I was looking. So we would really just return mid. And Then if it's not found, we return -1. So let's go ahead and see how this code functions. Hopefully we got it somewhat right. And we can say, so in this case, we are looking for 9. It's going to return the index, so 0, 1, 2, 3. Let's see what we get if we look for 22. And we've got 6, which 0, 1, 2, 3, 4, 5, 6. So that checks out. Now, what we want to do is we want to look at real quickly. Let's look at the runtime. So this is where the magic of binary search really is, because since we are having the search space each time, we have a log n, which is a great runtime. And our space complexity will be big O of, it's basically constant, so big O of 1. Now, if we were, because of the call stack, if we were to use a recursive solution, we would be looking at log n as well for our space. This is, again, recursive because of the call stack, but here we've done an iterative approach. So thank you so much for stopping by.